Hello all, welcome to our channel. So in this video we will talk about isolated power planes in PCB. So what is this term isolated power planes? So to understand that, let us assume we have a PCB. Okay, so on this PCB, uh, like generally the PCB planes could be number of layers, right? It could be 2 layer, 4 layer, 6 layer, 8 layer, whatever, based on the requirement. So for these particular layers, we will have a stack up where the stack up defines the kind of routing that can happen. Like example, the top could be is always a routing layer, right? The next layer could be a ground, and then so on, signal, ground. So the distribution of the routing on how the planes can be present inside a PCB can be known by the stack up. So now it is common that we see power planes, ground planes as a part of that stack up in our PCB. Now, sometimes when you see, there will be small planes, um, whether it could be on the top layer or the bottom layer, um, or it could be in the inner power planes for a particular section. Example, we can talk about a DDR3 where a specific part of the plane is restricted to that particular voltage. So we generally see those scenarios. So why do we do that, or what could be the advantages of it, or where other than the example we talked about, these scenarios can be used is, for example, let us assume we have a circuit where that circuit could be a high frequency operating circuit, or it could be a very critical circuit with respect to functionality, where it need to be isolated from the other sections. Like example, we can talk about a clocking circuit, clock tree kind of circuit, or it could be a simple oscillator near the microcontroller or the processor. So all these are very critical, right? They are the high frequencies signals that are associated with them, which could affect the other parts of the circuit. So for that, generally what is being implemented in our circuits is they'll try to isolate the other sections. Like example, so the dots what we are seeing is the gap between this plane and then the other planes, whether it be routing might be there, or there could be another plane around this. So whatever, so this plane shall be isolated. So now what happens is, whatever the noise that is present in this plane may not affect the other planes. Vice versa, if you want to isolate this, or it's a plane which gets affected easily by the noise, you can have it separated from the other planes. So that is how we use isolated power planes, where it may not be a bigger power plane, it should be a smaller area which is restricted to that particular point, so that that point might not affect the other circuitry, or in cases, as we said, it might not get affected by the other noisy circuits around. So a very very simple implementation. So generally, how do we do with those is, let us assume this is the plane. So to this plane, definitely will have power, right? So underneath this plane, you should definitely have a ground plane. Let us assume this is the immediate layer. Okay, this is the power, and then at the entrance of this particular plane, you will immediately have a capacitor such that a proper filtering happens, and any noise that is being generated gets filtered, especially the high frequency noise. That's how this is implemented, and how we use the isolated power planes. Like example, if you have used such in your PCB where you have taken care, please post your comments here. Please let us know your suggestions, or on how you have implemented and what are the cases you have taken with respect to your circuit. Thank you.